Right, welcome to the first explanation of the WIC, so geometric sequences. So in class, we already kind of went over the idea of it, and most of us already actually derived the equation, and it's very connected to what you did project. So there's this video, right? We all know social media. We know this is Lalo and Andy, two students in our classes, and now that you're done probably laughing because of the pictures, social media, when something is trending, it means that it's a lot of people are sharing it, a lot of people are looking at, liking it, whatever it is. You have MySpace, Vine, Kick, all these other different types of things that you look at. This is day 0, and Andy and Lalo took this really funny picture of this like cat on a skateboard running down like some street in downtown, and they want to share it. So they put it on Instagram. They both put one picture. On day 0, we only have 2 people. So we have one here. Let me change the color tree. We have Andy and we have Lalo. So on day 0, we have 2 people. And they find out that 3 of Andy's friends and 3 of Lalo's friends also shared the picture. So now how many do we have? Now we have 6. So now we have 6 students that saw it on day 1. Let me change the size of this. Shared it with 3 other people. So now we have 1, 2, 3, 5, 6, 6. How many people total? You probably guessed it already. 18 people total. From day 0, we had 2. Day 1, we had 6. Day 3, we had 18. So let's look at this in a graph. About this, there is a pattern. So it goes from 2 to 6. From 6 to 18, how many do you add here? 4. From 6 to 18, you add, what is that? 12. From here to here, you add some weird number. Before, we had it where you add 4, you add 4, you add 4, you add 12, you add 12. You add 12, it was something common. It was a common difference, right? Now it's a little different. So let me start over. Let's think about another pattern. We already saw this in class, but from here to here, you multiply by 3. From here to here, you multiply by 3. From here to here, you multiply by 3. So there still is a pattern, it's just not addition, it's a geometric sequence. It's what we're learning about this week. Last week was arithmetic, was adding, this week is geometric. So what's another way to write this? Let's write this, because you know I love writing stuff in different ways. So this is just equal to 2. This is equal to the previous times 3. This is equal to, you probably guessed it already, 2 times 3 times 3. Make sure you're writing these notes down. 2 times 3 times 3 times another 3. Now what's the pattern? It's the exact same thing we did when we were adding. Let's see if we can guess what it would be down here. Well, how many 3's do we have here? 2. It's not a coincidence. How many 3's do we have here? 1. How many 3's here? 0. How many 3's here? 3. So how many 3's do you think we're going to have when we have x? Probably guessed it. You're going to have x 3's. Oops, let me erase that. 2 times 3 times dot 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 times 3 times new 3. How many are we going to have total? Well, we're going to have x total. Now, let's rewrite this one more way. Let me zoom out a little bit so that I have space. La formula. All right. Let's write this using an exponent. It's 2 times, it's a times sign. Just pretend like that's a times sign. 3 to the what power? Second power. Over here, 2 times 3 to the what power? Third power. 2 times 3 to the 1, or you can just write 2 times 3. Now over here, here's the tricky one. What goes up here? If this is 3, 2, 1, 0. So what do you think it's going to be when you have for term x? For this one, right here, we had 3. For this one, 2, 1, 1, 0, 0. What's going to be up here? You probably guessed it. It's x. So that is our equation. 2 times 3 to the x. Stay with the pink. Let me make it a little bit thicker. So our equation was a to the n, that means any term, is equal to our beginning times our common ratio to the n. n is the same thing as x. So let's look at what this actually means. Let me get a different color. So 2. 2 is our beginning. 2 is like our b, and y equals mx plus b. 2 is what we started off with. So let's call this the initial. And 3, what's 3? You probably already guessed it. 3 is our common ratio. So we multiplied from one step to the other. So from here to here, you multiply by 3, multiply by 3, multiply by 3, keep going down, keep all the way going down for anything. And n, last term that you probably already know what it is our term. It's our x. Okay, so to sum, if I'm going too fast, the total number is equal to the beginning, which is 2 in this case, times the common ratio. It's always going to be times the common ratio. Remember, you can have a positive or a negative common ratio, which is we multiply from each one, raised to the nth power, where nth is our term. In this case, we had times 2 times 3 to the n. That was our formula to find the number of, I'll call it seats. It should not be seats, it should be people. Let me write that real quick. Total number of people for any stage. In this case, I think it was weeks. Now, in this one, how many people will see the post on the 14th day? So 14 days, remember, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many people will see it by the 14th day?